Hi everyone, we are Team 6 and our project topic is about post-wildfire air quality prediction in California. Our project purpose is to use wildfire features and the weather features as inputs to predict air quality in California through some machine learning models. Our project scope is in California only, and the time frame is from 2000 to 2015. In this project, we have three raw data sets. They are wildfire, weather, and air quality. Here is our today's agenda. We're gonna begin with data pre-processing and then talk about training and test data preparation. We have also created a website for visualization and demo purpose, and we're gonna show the website in detail in the data analytics result part. And we're gonna finalize our presentation with the ongoing machine learning results. Let's talk about data pre-processing. Since there are many columns in the wildfire data set and only part of them are relevant to our project, so the first step we did was to select those columns related to our project. Since the discovery day of year and the time was in a integer format in the raw data set, we have to convert these two columns into date time format for our future data processing and modeling purposes. And then we calculate the duration for each wildfire, and that is also a reason why we have to convert the start time and end time of wildfire into daytime format.
Yeah, so because the FIPS code, also the county code, is one of the input in our X data frame. So there are some non-value here. So we are going to fill this data by calling the government provided API through by the longitude and latitude. So this page shows how we fill this non-value in the FIPS code. Next. So on this page, because we are going to we merged the weather data into the final file data. So we going to merge the mean precipitation, the mean max temperature. So this show how we merge it. So we merge this file by calculating the mean value between between the start day of the fire and the end day of the fire. So we merge this weather information into the fire data, which will also be treated as the input. Next. So this page shows how we get our target data, which are the air quality data. So our air quality data was fetching from the EPA provided web API through this function. And we fetched, we totally have three different air quality index, the PM 2.5, the CO, and also the ozone. Next. So in order to merge our air quality data into the file data, we also use the same logic as how we calculated the weather data before. So we calculated the mean value for each air quality index between the day of the fire and also the end day of the fire. Yeah, next. So finally, we get our final data set. So we're going to separate into the X input input data frame and also the output data frame. So we totally have 6 different columns, 6 different input features, and also 3 output features, the ozone value, CO value, and the PM 2.5 value. And we also expand the FIPS code by the get dummies. Next. So here is how we also split our data set by 80% to 20%. Next.
Okay, and then the third part of this presentation will be our data analytics result. So basically, our data analytics result will be showed on our website, which we will cover later. We will actually going to navigate you guys into our website so that we will discuss in details then. But right now, let me give you a basic tutorial of our website. So our website, we contain several key features. Each of those features are represented as one of the items in the navigation tab. So in total, we have 5 navigation tabs. So the first one is our general overview of the welfare related statistic, and then the welfare information. The second one will be our data preparation journey, including our data cleaning procedure, including our source code. The third one is our data exploratory analysis, our EPA, and which basically includes 2 parts. The first part will be a tabular-based time series animated impact visualization, which user can actually click and drag through the time, and then they can see the impact of the fire through time, which is an animated feature. And then the second one will be the Python enabled and Python generated 2D and 3D plot we generate from the Seaborn and the Matplotlib. These are served as not only the data visualization part, but also as the important tools for us to filter and then to help us understand the data better, and then help us understand what is missing there, and then what are some of the outliers so that we perform better in the data cleaning process. And then the fourth part is our machine learning model prediction part, which enables the user to make their customized AI-powered welfare impact prediction on whatever value he or she chooses to use. And then finally, so right now we are going to show you guys the web page on our local machine, on our local host. But eventually, we plan to deploy on the AWS, which is the Amazon Web Service server. And then we are going to use the Elastic Bean to perform this. Our purpose of doing this is because we want everyone to use our website so that they are able to benefit from it. So for example, the firefighters can know from like the instantaneous fire news, and then for example, some researchers can know what are the impact of our fire can be from our AI powered model. And then following, there are some images which includes our basic, each tab is like what each tab looks like. This is our first tab, the main page. And then this is our second tab, which is our data preparation page. We include the raw data source. All of those buttons are clickable, by the way. And we have our 2D plot, 3D plot, which we are going to talk in details later. Our raw Jupyter code file, and our tabular-based animated fire impact visualization file, the tab. And then we have the machine learning prediction page, which user can input their customized feature on the left-hand side, and then our model will be transmitting the data from the backend to the front end to display to the user those key values. And then now let me navigate back to our website, which is shown right here. So Joe, why don't you guys start?
So what you're looking at is our homepage for the website we have designed. And this is fully functional with all the information about how we did the project and machine learning models results. There are 6 tabs up top, as David talked about in PowerPoint, and we will go into detail about each of them later. At the bottom, we gather some stats to just show how much damage the wildfire have done to our environment as well as the economy. When we scroll down further, there are 4 machine learning models we have tested, and we ended up using ANN for our final model prediction because A has the best accuracy among other models. Yeah.
Okay, Joe, why don't you talk about the data preparation part? So now let me click the data preparation part, which will navigate us to the second tab.
So here are all the raw data we have collected with all the detailed info, including all the important columns we gathered and generated. They're all clickable, and once they're clicked, you can see the source popped off this is where we download the data from. Yes. And they're followed with steps to prepare the data. First, what we did was that we cleaned the fire data and we applied the feature selection, and then we performed serialize onto weather data, so that make them Python readable as an object in dictionary. The last step is that this is how we create the data set that is ready for machine learning training.
Okay, so now Shize is going to talk a little bit about our 2D and 3D plots.
Yeah, so we also generate a bunch of 2D plots and 3D plots to help the user to visualize how is the impact of the wildfire. So for 2D plots, we are generating the variation of the air quality before and after wildfire, because we want to visualize how the wildfire will impact the air quality. So like for the image 1, so this is showing the ozone value change in the county number of 43, and from the during the year 2001. So actually, this red rectangular is the interval for this wildfire. So we also have the similar the other like the similar images showing different air quality index like the PM 2.5 and also the ozone. And for this plot, for the underline plot, the 3D plot, it shows the variation of the air quality based on time and fire sites. So like the first image. So the x-axis means the each day during one single year, which means it will have 365 value. And the y-axis is the fire size. And the z-axis is the air quality index value. So the reason we generate this fire, because we discovered during some year there will be several fires happen, and also because always the fire will impact each other. So in order to except for only discovering one single fire, we should see all this fire as a bunch of cluster, so that this impact will have a more significant change. So because we also find that the fire size will definitely have some impact to the air quality index, so we generate this 3D plot. Yeah, so this is the visualization part we did. So for the third tab, this shows our resource code, and we totally have 5 main code provided by the Jupyter. And in order to have other maybe the user to know how we process our data and how we drive to our machine learning model and how we analyze, we provided our original code and we published to the GitHub Gist. And so the first tab shows how we fetch our air data, and the second tab shows how we combine the weather data, the air data, and also the fire data together to generate the machine learning model ready dataset. And the third tab shows how we drive to our final machine learning model, and also this part can be improved later and to improve the accuracy, like also the variation. And for the first part and the last part, it shows how we draw the 2D plot and 3D plot just as shown in the second tab. Yeah. Yeah.
Okay, so now Joe is going to talk a little bit more about the Tableau animated fire impact visualization. So Joe, could you request control?
Okay. All right, so this visual on our website is done by using Tableau Desktop and embedding them from Tableau Public. In this project, the data is gathered and prepared based on geographic info, and Tableau provides an extremely easy to implement environment to represent data as a map format after some dragging onto data dimension and acquired data measures such as fire size, air pollution stats, and geo information. We have designed the visual as a format of a Tableau dashboard containing two maps as filters for each other. And there's also a draggable page legend that serves the purpose of picking a specific date range, and moving forward along the timeline automatically to represent the data as a tooltip on map point. When you click the play button, you can see the timeline going forward and all the fire that happened during the time. So the left map points out every wildfire at exact location given longitude and latitude, and the right map gives wildfire that happened during the time by county. So when I pause, for example, this is all the wildfires happened in November 2003. And when we click on the county, and the tooltip will show, give the exact number for the summation of fire size, CO, ozone, PM 2.5 concentration, as well as the temperature at given range. So yeah, this is our visual.
Okay, so now let's talk a little bit more about our fourth step, which is our fifth step, which is our air impact prediction tab. So in this tab, the user is going to be based on our AI powered model, which is our ANN model. The user on the left hand side is going to make his or her own prediction, and then on the right hand side is our prediction result for the air quality metric. We have CO, ozone, and PM 2.5. So when the user input the fire metric, there are several key input features that they need to enter. So as we know, our project is based on the California wildfire. So the first one will be including all of the counties in California. The second one is the fire size. The third one is the duration of the fire, the mean precipitation, and then the mean temperature, max temperature. So for the demo purpose, let's just do one. So for example, if I choose the Orange County, and as a fire size, let's just do 3,000 something. And let's do the duration of the fire to be around 46 days. For the mean precipitation, let's just do 0.39. And then for the mean temperature, let's just do around 45. Max temperature during the fire interval, let's do a little bit higher, around 95, because it's a fire season. So let's predict it. And then when the data is sent into the backend, which loads our model. And then our model is going to, based on this input, on those input numbers, is going to give the user the result. As we can see we can have the CO value, ozone value, and PM 2.5 value. In order to help the user better understand what those value means, we have those legend illustrating what is the corresponding interval this value falls within. And then our last step is just the About Us page to demonstrate our group members. So now let's go back to our presentation. So as we did in our website, as I briefly mentioned, we have three models. So our first model is going to be our ANN model. Our second model is going to be our RNN model, which stands for Revolutionary Neural Network. And then our last model stands for the Gated Recurrent Unit model. So as we know, our ANN model stands for Artificial Neural Network model, which is our basic model. As we can see, for all of those three models, each one is predicting the ozone, CO, and PM 2.5. And then as we can see from the line is all going have a downward trend, which means as the epochs and the data are growing, the model is So the model is trying its best to fit our data. And then, so here we have 3 models and then 3 prediction and validation result as along with the epoch increase. So in order to pick the best performing model for each of the metrics, we have 3 metrics, right? So we have CO, ozone, and PM 2.5. So we are going, so probably one of the model is fitting for the one, and the other model probably fitting for the other metric. So we did, for each of the metric, we are evaluating which model will be the best fit for that model prediction. For the CO metric, as we can see, for the AN model has the best performance, 0.043. And then surprisingly, the ozone model, so surprisingly, our AN model is also the best fit for the ozone, which has the lowest loss. And then for the PM 2.5 is also our AN model has the lowest loss. So therefore, in our website, we in our backend, we save the model for the AN, and then we take the user data and then use this AN model artificial neural network to do the training and we finish the training to perform the validation. As we know, so not only our website needs to be published, but also our machine learning model is also in our development phase. So as the time goes on, we are planning to add more and more model. And then we are trying to increase the accuracy and try to make sense more about the model. As we can see right now, all of our model is our deep learning model. So in the future, we probably add some machine learning model, for example, like random forest decision tree. In that way, we will able to make sense of the model and then understand why those models perform better than the other. Okay, thank you for the presentation.